share my screen. I think I need to share in such a way that I can see. Okay. Blue turquoise. Okay. Okay. All right. Let me share my screen now. Uh, okay. You can see my screen now.
Yes, sir.
Okay. So let's see the first one. The first one is x squared plus 3 times sod 3x plus 6. Okay. So, hmm, uh, okay. Okay. Let me see. I'm really looking at this thing because of that sod that is there. Trying my best to be careful with it. Okay. So, plus k, no, x squared plus 3 x squared plus 3 sod 3 x plus 6. Okay. Um, okay. So if I liken this equation to, if I compare it to ax squared plus bx plus c. So that means my 6 will be c, my b, all this will be my b, then my a will be whatever is multiplying x squared, which in this case, even though there's no number there, we assume the value 1 is there, right?
Yes, sir.
So we understand this. So this ax squared plus bx plus c is the, should I call it like a general pattern that all quadratic equations follow? Now, does it mean that every quadratic equation will have 3 terms? Not so. may not. But one thing is sure, every quadratic equation will have the um what do you call it? The order, one of the x or one of the unknowns in it will be of the order 2. That means the highest power of the unknown in that equation is 2. So that's what we'll refer to as the general formula. Um, yeah. Okay. So let's take it step forward. All right. So if we had to factorize this with, of course, the assumption that it could be equal to zero at some point, then this is what we will do. Um, Let me quote the formula. Minus b plus or minus square root of b squared minus 4ac. Okay.
Yes, sir.
Um, all divided by or all over 2a. So yeah, so let's see how this plays out now. Um, our B contains a surd, so let's not forget that. Now, of course, I wrote it out like this so that we can clearly see the the signs, whether they're positive or negative, that's in front of the coefficients of each one. So once we have that at the back of our minds, I think we can proceed with that. So B is going to look something, or it will look something like this. Minus B, sorry, I'm starting, I want to, what do you call it? Substitute them. Minus 3 sub 3, uh, plus or minus square root of, now, this is where we need to be careful because of the sod. 3 sod 3 uh, squared minus 4ac is 4 times 1, 4 times 1 times 6. Okay, so we've got that down, and then we'll now say all over 2a. So that's like 2 times 1. Okay, all right. So now that we have this, let's see how we'll progress from here. So I still have my minus 3 sort 3 in there. Okay. Plus or minus. Um, Now in that square root, so let's evaluate what that square of that sum is. Now you remember in indices, there's a law. Maybe I should quote the law somewhere around here. so that you know that it was here that I applied it. The law says something like this. It says that x uh, raised to the power of a times y raised to the power of b, and all this raised to a power c, that this will be equal to x raised to the power of a times c. Sorry, that doesn't look like c again because I modeled it up. Okay, so that would be equal to a times c, and then still preserving the multiplication that was between x and y originally, times y raised to the power of b times c. So in other words, the power outside simply goes inside and multiplies the individual powers. Do you remember this law?
Oh, yes, that one. Yeah. Power
Okay.
inside, power outside.
Yeah. Okay. All right. So if this is the case, then that means that what I have here, where you have 3 times sod 3, that sod 3 is just square root of 3. That means 3 raised to power half. That's what square root is, a power of half. And then the 3, its own power is 1. So that means this will be equal to 3 squared times 3. That's 9 times 3. Okay. Which is already looking like 27. Now, I'm sure you understand why it is 3 on this side. When you square a square root, it takes off the square root. Or if you want to look at it another way,
No,
the
it's fine like
2
that.
multiplying the half, yes, it becomes 1. So it's out. And then on this side, we have 24. Okay. So I think the insides of this thing is looking like it's being resolved now. And it's only the outside that looks kind of like, okay, waiting for you. Okay. So so under that square root sign, I'll have 27 minus what?
Minus 27.
27 minus 24, isn't it?
Yes.
Uh-huh. And 27 minus 24 is what?
3.
That's 3 exactly. Okay, so everything is looking nice. If we push it further, that's going to leave us with 3 sod 3 plus or minus sod 3 again, which makes it kind of easy because sod 3 can now be factorized. Okay.
Okay.
Yes, it's common now because, okay, so remember that all this while, it has been x equals, so let's not, I forgot to put that at the beginning. Maybe I'll do that. Okay, let me just do that now so that I don't forget. X equals that. Okay. So yeah. All right. So we will understand that it's X all that while. Okay. So if we factorize sort 3, what do you think it will become? Maybe I should just push it on this same line. Sort 3 is common. So You factorize it, what will be left inside the bracket is minus 3, isn't it?
Okay, yes, sir.
Now, um, don't worry about the plus or minus. We'll come to that plus or minus when we're separating them. Plus or minus 1, right? Because
Mhm.
it's going to take itself out. And all this is over 2. Now, so the two values for x are either x equals sort 3 minus 3 plus 1. Okay, so I'm going to, what I'll even do is I'll put them side by side over 2, or x equals sort 3 into bracket minus 3 minus 1. Okay, so I'm sure you can already see how it's going to play out, right?
Yes, sir.
So on the left hand side, I have minus 3 plus 1 is what?
Minus 3 plus -2.
Minus 2, correct. So that's minus 2. So if I write it on the next line, I have minus 2 so 3 over what? 2.
2.
And you can already see what will happen there. The 2 will cancel itself. Or um, minus 3 minus 1, that's what?
That's -4.
Minus 4. Or minus 4 so 3 over 2. So things can take care of themselves now. 2 will go into itself one time. 2 will go into itself minus 1 times. 2 will go into itself once. 2 will go into minus 4 minus 2 times. And what do we have? X is either sort is equal to sort 3. Okay, so let me write back our x because this is where we have to come back to the original. Or x equals minus 2 sort 3. So, um, yeah, and then if I want to take it back to the original bracket, the sort 3 on the for the one on the left will move um to the left hand side, and that will make it plus sort 3. So x plus sort 3, that's the first bracket. And then the second bracket will be x plus 2 sort 3. Okay, so did you get that?
Yes, sir.
All right. Okay, so do you want to do a screenshot or I should send you the file after we're done?
Okay, you can do that, sir.
Okay, I'll do that. I'll send it to you on WhatsApp.
Okay, sir.
Okay. Okay, so let's go on to the next one. The next one says x squared plus 2 sod 5x minus 15 x squared. That's the second. Is it Roman numeral? Okay, Roman numeral 2. Okay, okay. X squared uh, plus 2 plus 5 x and a plus again. Minus 15 this time. Minus 15. Okay. All right. So the same thing we're doing with that last one. But let's just pretend that we have the model in our mind. So this will be my A. My A will be 1. Okay. My B will be all this. And then take notes, we're taking the sign, even though here the sign is positive. And then my C will be all this. This will be my C. So what I'm going to do now, I'm not going to quote the formula again. Okay. So I'm doing it based on the picture I have in my mind, which is this guy. Minus b plus or minus square root of b squared minus 4ac all over 2a. So I'll just be substituting it, and let's see if that will give us some leverage in terms of time. Okay, so let's go. So that's going to be mine. I'll start with the unknown. In this case, the unknown is x. I'm sure by now you know that sometimes the unknown may not be x. It can be another letter. So depending on what the letter is, always remember to adapt and, um, make your formula match with whatever letter it is that is given by the question. So in this case, again, it's x. So x is equal to minus 2 sod 5, right?
Okay.
Plus or minus, okay, um, 2 sod 5 squared, okay, minus 4ac minus 4a. Now, I see in this one it's not positive again, so we have to be careful about whatever it is we're doing here. Okay, so here we go. And then we now do this all over 2a, and our a is still 1. So it just aligns itself. And on the next line, what do I have? This guy still stays the same until we're done with the guy inside what we call the discriminant, or what is called the discriminant. Um, what is the contents of the square root under the square root sign. And then now, if I square, of course, in your mind again, you can apply that indices law. The square will go inside and affect 2 and become 4, isn't it?
Yes, sir.
Then it will also go inside and affect sod 5, which is as good as what? 5. So you can do this times 5. So 4 times 5. You put that there. Maybe you can put it in a bracket to be on the safe side. Minus. Now, because of this minus 4 and minus 15, automatically that minus will become plus, isn't it? And
Yes,
all we
sir.
now have is 4 times 15, which is
60.
exactly 60. So those are some numbers which you already know their answers even without punching your calculator. Things like 25 times 4, 100,
100.
yeah, numbers like that. Of course, we have two underneath, so our next line will now look much simpler. Our next line will look something like this. Um, X equals minus 2 sod 5, okay? Uh, plus or minus uh, square root of. Now on this side, I'm having 20 times 6 plus 60. That's 80, right?
20 times. What did you say?
20 plus 20 plus 60.
Yeah, 80.
So this 80, we can still break it down. We can break it down. Um, so that's what will happen in the next line. We're going to break it down so that it will look much simpler. And if we're breaking it down, I think it will be wise that we break it down so that sod 5 will show up somewhere. So in my mind, I'm thinking because out of all the things that can divide into 80, 5 is one of them. So because I'm targeting sod 5, I will also use sod 5 and see can 5, what will happen when 5 goes into 80? 5 in 80 is 16, right?
Yes, sir.
Okay,
Okay.
so that already gives me something I can work with. So if it's 16 and all that is under the square root sign, then that means that this thing is going to be as good as minus 2 sod 5. Sometimes I like to do the next line on the same line so that I don't have too many lines, underneath. 16 times 5. And of course, I'm sure you know what will happen. Whenever one of those rules of sorts says that when you have, in fact, it's not even, it's that same, what do you call it? That same law of indices is still an extension of the law of indices that the sword will simply split itself over 16 and 5 so that this guy will now look like this. Minus 2 sod 5 plus or minus uh, sod 16 is 4. That square root of 16 is 4. And then your sod 5 comes to play. So that's it. All right. So are you good with it up to this point? Yeah,
Yes,
following
sir.
up to this point.
Yes, sir.
Excellent. Good, good, good. Okay, so let's move on. Let's move on. So all this is equal to x. So the next line should be, I'm sure you can see sod 5 again coming to play. So maybe if we even do like that, you should just factorize it at once. So I have sod 5. If I factorize it, I have minus 2 plus 4, okay? And then all over what? 2 or sod 5 into minus 2 minus
Minus
4.
4.
Yeah. And then all that is still over 2. Okay. So, yes. So let's see what happens next. Minus 2 plus 4 will give us what?
Minus 2 plus 4, that will be plus 2. Plus 2.
Sorry, my internet tripped off for a bit. Okay. Can you see my screen now?
Yes, sir.
Okay, nice. Okay, so let's progress. So that's going to be you said -2 plus 4 was what? I didn't hear you back there.
+2.
Plus 2. Okay. So that's going to be 2 sub 5 over 2, which we all can see what will happen there. Um 2 will cancel 2, 1, 1. Or x will be equal to -4 -2 -4 will be -6, isn't it?
Yes, sir. -6.
-6 sub 5 divided by 2. And now you can see this guy playing nicely to become -3 sub 5. And we have that x equals sub 5 or x equals -3 sub 5. And of course, you can, if you now move things to the other side, from the right hand side to the left hand side, we'll simply have that x uh, minus sub 5 would have been inside the first bracket. So we just simply put it like that. Or, and then, sorry, not or again. We just put the second bracket. X plus 3 sub, sub 5. Okay. So are you good with it? Are you clear with this up to this point?
Yes, sir.
Okay. So, um, let me see. So there's a third one, right? Hmm. So I want to do something. Um, okay, we still have a lot of space back there. Okay. So I'm thinking maybe we should. Okay, no, let's just continue. The third one. Okay. Okay. This third one seems to give us something slightly different for A. That's 2x squared minus 5 plus 2 minus 6. Okay. All right. So this is how this one looks. Um, of course, without much ado, we know that this is our A. This now, be careful now, because of the sign. All this is going to be our what? Our B.
B.
And all this is going to be our C.
C.
Yeah. Okay. So once we have that all sorted out, all we need to do is to start factorizing. X will be equal to, now, because of that minus B, we have to put, all this while we've not been putting, if you look at it, we've not been putting B inside any bracket. We just put minus B and then go ahead. But now, B, and all this while B has not had any minus sign. But because this one B has a minus sign, we have to write it like this with inside the bracket before we now, of course, remove the minus sign because we know it is going to give us a plus. Okay, so
Mhm.
yeah, so we have minus B plus or minus square root of B squared. And this one too, we have to be careful to uh, reminding ourselves that there's a minus, but it doesn't make any difference because the square of a minus of a negative number is still a positive number, you know. Minus 4AC minus 4. Now my A is no longer 1, but 2. So anyway, it's not like we have not even been writing it. We've been writing it even though it was 1 all this while. And C is minus 6. Okay, so all this is over 2 times 2. Finally, 2 now has a partner that's not 1. Okay, so of course, I'm sure you can see what's going to happen there. X will be equal to the minus minus will become plus. So I just left with 5 sub 2 plus or minus. Now, let's be careful with what's going to happen inside this square root, big square root sign. Um, the squared will affect minus 5. Minus 5 times minus 5, that's minus 5 squared, is still what? 25. Okay. Um, then the squared will also affect 2. So it will be 25 times what? Times 2, isn't it?
Yes, sir.
Okay. All right. 25 times 2. Then we'll now, the same thing that happened in that, the question we solved before this one, that's number 2. Minus minus, we're sure is going to give us a plus. 4 times 2 is 8. 8 times 6 is 48. Okay. So we'll just put our 48 there. And of course, I'm sure you can see that it's going to give us a big number, but it's not something we can't handle. Remember the way I handled it in the previous question. We're going to do exactly the same thing here. Okay. So here we go. 2 times 2 underneath is 4. So no need to rewrite 2 times 2 again. So now 25 times 2 is 50. 50 plus 48 is
98.
98. Now, remember how we did that other number. What are we going to be thinking in terms of this time? What will we be thinking in terms of? Because the sword here is sword 2. In that other question, the sword was sword 5. So we thought we broke down 80 in terms of 16 times 5. So in this
Okay.
case, what do you think we'll do?
Mm, so it would be, are we going to like divide 2 into 98?
Yes, yes, exactly. We're going to break down 98 uh, using 2 so that because we know where we are going, we know what we want to achieve. That's our goal, to have a sort 2 somewhere. So 98 is what times 2?
Is 49.
Exactly, 49. So I can now write my next line as what? 5 sort 2 um, plus or minus. Um,
Mm.
now you can even see what's going to happen under that bracket, isn't it? Because square root of 49 is 7.
Yes.
Uh-huh. So, but of course, we all know that square root 2, 2, 2 is better left as a square root, as square root of 2, so that we can easily evaluate it in our question. So this will now become, um, oh, sorry, I think I've miswritten something when I was, I was talking. Okay, so it's actually 5 sorts too, please. Let me wipe that thing that looks like a bracket around it. It can confuse somebody. I'm always careful about my own handwriting because what your eyes see as you're working, doing your work can be the difference between one step and the final answer. One step can just change radically just because you mistakenly wrote something that you shouldn't have written. So square root of 49 is 7, and of course times sod 2. So here we go. And we can now go on to the next few steps, which would be x would be equal to. Now you are free to factorize the sort too, isn't it?
Yes, sir.
So we factorize sort 2 there. That will leave me with 5 plus or minus 7. Um, and of course, you have your 4 nicely there underneath. So that tells me that therefore x um, will be equal to sort 2 uh 5 plus 7 is what?
And 35.
No, plus, so
Oh,
plus
5 plus. Oh, sorry, that's 12.
12, yes. So that's going to be 12 sort 2 over 4, or x is equal to 5 minus 7 is minus 2, minus 2 sort 2 over 4. Okay, so what's that going to give us? 4 in itself is 1. 4 in here is
3.
3, yes. So that's mean x equals 3 sort 2, yeah, or x is equal to what? Um, okay, 2 in itself is 1, 2 in 4 is 2.
3.
So that's minus sort 2 over 2,
2.
which you can technically write as minus 0.5 because of the half. You can write it as minus 0.5 sort 2. Do you agree with that?
Yes, sir.
Okay, nice. So that makes our work easier. We can now say the two brackets that we have are x. You take that 3 sort 2 over to the left-hand side. It will be x minus 3 sort 2. And if you take the minus zero point 0.5 to the other side to be x plus 0.5 Uh, Surds 2. Okay. So, are you good with it?
Yes, sir.
All right. So this is how we solve these guys using quadratic formula. Yeah. Okay, let me put this in a box. So when you're looking at it, you know that it's just an indices law that I was applying. Then, okay, so let's look at how the next questions look. Um, so this next one, right? Using both sum and difference of two cubes, factorize the following. Hmm, okay. So this sum and difference of two cubes. Okay. Okay. All right. So this one requires us to remember some things, which it's not as if you can how will I call it? Maybe you can prove it mathematically, but I don't think anybody will want you to prove it like that because it's just one step in solving the question that's coming up with what I'm about to write out. But at the same time, it's important because that first step can determine whether you will be able to solve these questions or not. So I don't know if you've heard of this difference of two squares before, have you?
Difference of schools now.
Difference of two squares. Okay, sorry, let me ask. I know that we're doing 2 hours today. Do you want to take a short break, like 5 or 10 minutes?
Okay.
All right, let's just do 5 minutes. We'll come back.
Okay.
But you can stay in the class. You can keep your device connected. Just 5 minutes. I'm not going to take longer than that.
All right, sir.
Yes. All right. Okay. Hope you were able to stretch a bit.
Yes, sir.
Okay. All right. So let's go look at 52. Number 52. All right. So all these ones were doing was 51. Uh, hmm, 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 hmm. Okay. So number 52. Hmm, hmm. Number 52 is a cubed hmm, plus b cubed. Okay. So this was the part I was saying that you can't really, I'm not sure you can break it down, but you can use, they said sum and difference of two cubes. Okay, so sum and difference of two cubes has a particular format. It starts with a, a bracket that contains what you have on the left-hand side exactly, but without without any power. Okay. And
Okay.
then in the second bracket, you have squared. And what comes after a squared is the flip sign or the opposite sign of whatever was in the expression on the left hand side. So the opposite sign to addition is subtraction. Then you have, sorry, uh, A, B plus B squared. Okay, I'm thinking I left out something. It looks like I left out something. My A is A plus B um, into A squared minus AB plus B squared. Hmm, is it? I'm thinking. Okay, okay. Um, okay, okay. What I'm checking is if these guys are actually the same, um, or not. A plus B, right? Hmm, yeah, think I think this is it. I think this is it. It should be it. Should be it. Mhm. Mhm. Okay. Mm. So, when they say we should use sum of cubes and difference of cubes, this is basically what it will come to. All right. This is basically what it will come to. There's no, I'm not sure we can do it. We can go beyond this.
Yeah, I think that's the. Oh, we
Hmm.
like open the bracket.
If you
Yeah,
open the bracket, you are
I
going back
understand
to,
this one because we've done it before.
okay. Okay. So if we open the bracket, you know what, it will still take us back to the left hand side.
Yes.
Uh-huh. So I think I'm not sure we can break it down beyond this.
No, we cannot. It's just like that. I think that's
Mm.
the formula.
Okay, okay, okay.
So
So
it's
this is
just
for the
that in numbers, like sometimes it can be 7 cubed plus
uh-huh.
6. So we just have to sub it into, and then we just use
Yeah,
the number to sub everything out.
yes, yes. Okay. All right, so let's look at the second one. I think that one is plus. Let me see. Oh, that one is minus. Oh, okay, this one was plus, so that one is minus. So for that one, I think it's just the same thing technically, but then where you have minus, you have plus, and vice versa. Uh, um, that would be A minus B, um, A squared. We'll flip the sign here, plus AB plus B squared. Okay, yes. Yeah, okay. So let's go to the third one. Third one says 8x cubed plus y cubed. So I think this one is like an application, right, of the formula. So, okay, so how would you apply this?
So is it the third one?
Yes, the third one.
So that would be B. Wait, yeah. So B.
Hmm?
Oh,
Do you want to start with the
wait, is
B?
that three or B?
No, okay, this is 8.
Oh, because I thought it was B. Sorry.
Sorry, okay, okay. This is 8.
Okay.
So I'm thinking we should first express 8 as a cube, which is 2 cubed before we
Okay.
start. Applying anything so that we don't get anything mixed up.
Okay.
Uh, then it will now be easier to put it in perspective. So I think, yeah, so now I think we can go ahead. So 8x cubed is the same thing as what we have on the right hand side, 2x all cubed. So we can now um, go ahead, and anywhere we see A, we'll put 2x, and anywhere we see B, we'll put y. Okay. So the first bracket is them without any powers. So that's going to be 2x plus y, isn't it?
Yes, sir.
2x plus y. And then the second one is going to be 4x squared, because when you square 2x, that's what you have. 4x squared minus AB. So in this case, that's 2xy. Just multiply the A and the B together. And then plus B squared. In this case, that's y squared. Okay. So I think this is it.
Okay.
Okay. So that's how number 52 played out. Uh, and it looks like 53 and the others are continuations.
Should we do
Okay.
55? Because I don't.
Which one?
55 and 55, one, and then three.
55, 1, and 3.
Yes.
Okay, okay. 55, 1 and 3. Okay. Okay, so the others would are going to be simple enough for you to handle, have you?
Yes, sir.
Okay. 55, 1 and 3. All right. Okay. All right. So let me just draw a line. I know that. Okay. Uh, I'll just okay. Pushed it further. I don't think I even get to that point. Okay. So 55 1. All right. So what does it say? 55 1 says a cubed minus 8b cubed c cubed a cubed a cubed minus 8b cubed. Oh goodness, that is not cubed. Okay. B cubed c cubed. All right. So if we apply the one of for difference of two cubes, then um just like we said, first bracket will be what? Will be each of them without anything, abi, without any
Yes, sir.
power.
Yes.
So that would be a minus 8 again is 2 cubed. So that would be 2bc. Okay. Then the next bracket is going to be them squared and then with a twist somewhere in the middle. So that's going to be a squared plus, that's why we flip the signs, ab, that is a times 2bc. So that's going to be 2ab c. And then finally plus 4b squared c squared. Okay, so do you understand how I came about that?
Yes, sir.
You understand, Abby?
Yes.
Okay, good. All right, so let's go to the next one. The next one is okay, you said 3, right?
Yes, the third one.
Okay. X plus y all cubed. X plus y. Hmm. This one itself, because of that x plus y all cubed, it's going to take its own. It's going to come with its own. What do you call that thing? Yeah, let me just write the 3 well. Minus z cubed or z cubed. Okay. All right. Let's see. So again, this one is going to be them first without brackets, without powers rather. So that's going to leave me with x plus y, right?
Yes.
Without any power, that's going to be minus z without any power. So let me just put that cross out so that it does not look like 2 by mistake. Okay, then the next bracket is them squared. So that's going to be x plus y. Okay, so you see as I'm writing it, we have to be careful with how we're writing it so that we don't confuse ourselves at any point. Okay, it's minus. Now, the real sign of this one, right? If you compare it well, this one is actually, this is the model that it follows. A cubed minus B cubed. You agree with that, right?
Yes, sir.
Uh-huh. So if that's the case, then we'll have to flip the sign from minus to what? Plus. Okay, this one is going to be interesting. So plus AB, and my A is x plus y, all that times z. Okay, plus z squared. Okay, all right. So let's see how it goes now. So on the next line, I think there are some things we can simplify. That first bracket will just simply become x plus y minus z. Since nothing really happened, there was nothing, no sign would change. X plus y minus z. Then if we open this other one, right, maybe I should still use the big bracket. This other one, right, x plus y squared. Now, do you remember there's another one that looks like this? The squared is not on the A, it's not on the B either, but it's on the combination of the A and the B. Do you remember this one?
Oh, yes, sir.
Uh-huh. And this one has its own. We don't have to come and start doing it here. But its own is looks like this. A squared
Plus
plus
AB.
2AB.
Oh,
No,
2 AB. Okay,
2AB.
because you're going to,
That's
yes,
it.
2 and B
Yes.
squared.
Eh, yes, thank you. Plus B squared. That's the difference between this one and the second bracket of the other one that looks like it. That 2AB in the middle. So if we remember this one, let me put it in a box so that we know it's not part of the working. It's just a law that we're picking up on. If we agree with that, then x plus y all squared is going to be x squared plus 2xy plus 2xy plus y squared. And, and then if we take it further, that's next one is x plus y times z. So that's going to be xz plus yz. And then we now have what? Plus z squared. Okay, so now because of the nature of this one, right, it has the potential to be taken further because it still looks a bit clumsy. And if we were to do that, then we would simply be collecting the guys that look like terms, and those would be the ones that look like terms. Let's see. Maybe we should take all the ones that have. Okay, so now which one we take it in terms of like terms? Okay, so you know what we'll do? We'll bring all the ones that are squared together. Yeah, I think that's the best. Yeah, okay, I think I've seen how I'll go about it so that we just have something that's kind of organized. This first bracket is already as simplified as it can be. No need to do anything else to it. Just write it down. Then this one now, I can take it in and bring all the squares together. So that's going to be x squared plus y squared uh, plus z squared. Okay. And then the ones that don't have squared, that have two letters, we can, okay, and that's technically the rest of it. Um, we just have plus 2xy. All right. Okay. Okay, I could do this plus 2xy, and then I want to make sure I don't leave anyone out. And then, okay, let me just group them. Can't, how many brackets do I want to have? Or should I, okay, maybe I should have just left. Okay, maybe let's just take that guy back to what it is. No, I don't know what to do. Let's leave it like that. XZ plus YZ. Yes. I think it's okay like this. Okay, so I don't think we left anything out, did we?
No, sir.
We didn't. Okay. So I think it's simple. It's simple enough like this. We can leave it this way. Can leave it like this. Okay. You have any questions on this one? You're good with this too, right?
Yes, sir.
Okay. All right. So, um, was there any other thing that you sent? I think it was this the only one you sent.
That was really well.
Uh, okay. So I guess the trained content was probably the one that you sent in our last class, Thursday. Okay. All right. Okay. Hmm. All right. So you're sure about these other ones, 53 and 54, you can handle them, right?
Yes, sir.
Okay, that's fine. All right. Um, okay, let me just see. I know if this one is straightforward for you. I guessing that this other one that I'm going to write now, you should know it too. You know difference of two squares, right?
Difference of two square.
Yes, the one that looks like this.
Oh, yes.
X, you know it.
Yes.
Okay, good. X squared minus Y squared equals um, X minus Y and then X plus Y. Okay. All right. So I think
Is that not
uh,
factorization or is just
it's still, yeah, it's factorization, definitely. It's
okay?
factorization. Yes,
Okay.
it is. And that time I was telling you that some quadratic equations look a certain way. So sometimes quadratic equations may not look like ax squared plus bx plus c. So this is
Yeah.
another variety of how they can look, you know. Um, and then you still be called upon to solve it. So you can apply this law if the one you're faced with looks like this or looks like this format where you have something squared minus something squared. Um, I am not sure a squared plus, is there anything like sum of two squares? I'm even thinking, sir. I'm trying to remember. No, it's only difference of two squares that is there. Maybe, let me see. Something is telling me that there's something like sum of two squares, and what will it be? But it's not definitely not going to look anything like this. Okay, but yeah. All right. So um I think these are the possibilities you have. I don't think there's any other one. Let me confirm. Okay, yeah, let's see. Okay, I'm just trying to confirm if what I said. Okay, okay. Yeah, makes sense. Okay, so the only difference, the one for sum of two squares looks something like this: x squared plus y squared, right, equals x plus y all squared minus 2xy. Okay. So, of course, if you look at it very well, I think it was even here that we were doing something like that. We were doing a plus b squared all squared. If you take out this middle one, you see that what you're left with is just what? A squared plus b squared, isn't it?
Yes, sir.
Uh, so that's it. We can put this in a box. Okay. All right. I think it's okay for us to, if you don't have any other thing you want us to look at, we can we can end the class for today. And
Yes, sir.
yeah. All right. So I'll save it and send to you on WhatsApp.
Okay, sir.
All right. You won't be going out today, will you?
No, I don't have school on Monday, so I'm just going out on Monday instead.
Okay. All right. Okay. Okay then. Enjoy the rest of your weekend.
Thank you, sir.
Mhm. So our next class will be on Tuesday. Yeah, I was going to ask you, have you guys ever done anything around programming, maybe learning a programming language, stuff like that?
Is it maths or?
No, computer science or computing. I don't know if you guys do computing
Oh,
as.
we do, but like I didn't choose it.
Okay,
I
why?
choose subjects. I don't really like some stuff about computers.
Why? That's
Is it why I don't like it?
mm-hmm.
I just don't have interest because I'm doing science in uni, so
Okay. Okay, so science, that's like you're looking at possibly doing courses like medicine, stuff like that.
yeah. Well, I'm not doing medicine, I'm doing nursing. But it's
You
still
are
it's
doing okay,
nursing. Nursing.
nothing. Oh, okay, okay,
Yeah.
okay. Okay. I think that would be safely classed under biological sciences now. Have you?
Yes, because I'm doing biology and chemistry. But it's all just because we're allowed to like choose any subject we
Mm,
want. So it's
mm,
just four choices. So you just pick
mm.
the one you want, the one you
Oh,
find easy and like. So
okay,
I do
okay.
biology, chemistry, geography, and business.
Mm, okay, that's good. What do they teach you guys in business?
More about like cash flow,
Mm,
marketing mix.
okay,
It's just
okay.
more about like how to operate business, how it works,
Mm,
um,
o-
how
okay,
like government rules in business,
okay. I see.
how to start
And
a
do
business.
they? Okay. And do they at any point give you guys like a project, like to
Mm,
actually see if
I have
you
a
can create?
I have
Mm,
projects in business, biology, and chemistry. So
okay, okay,
yeah, for the
okay.
business, it's just doing interview with like some shops to know how like digital technology is helping their
Uh-huh,
business. So,
uh-huh.
so we have to write
So
some.
using social media and stuff like that, right?
Yes. So,
Okay,
how is
okay.
it helping them and how is it also not helping them?
Mm,
So we have to
okay.
write like 1,500 words
Whoa, wow.
because it's
Mm.
40% of our
Your
like
s-
exam,
your
like
total scores.
yeah, state exam
Oh,
for next
interesting.
year.
Wow. Hmm.
Because now we don't
Okay.
do
Any
exam anymore, so it's just half project and then 60% for the exam.
really?
Yes.
Okay. That's interesting. Anyway, I think that approach would make it more more like a practical thing, like
Yeah.
you having hands-on experience with whatever
Yeah.
it is that you want to study further.
Yes.
Okay. Okay, it's a good thing. Though, if you ask me, I would have loved to pitch programming to you, but I mean, I know that you've already made your choices.
It
But
depends
yeah.
on what we are doing like I have interest
Mm,
in it, but at the same time, like what they do
mm,
here is just like it's not really about like programming, it's just more about learning
mm.
computing and stuff. So that's why I
Okay,
didn't pick it because it's
okay, okay.
they don't make it fun. So
Mm.
it's just
Oh,
boring.
I see.
People didn't pick it, so they just like canceled it. And it begin
Really?
because I'm in all girls school. They don't do
Mm,
they don't really do it. We don't do engineering because and we do woodwork, like if you want to do become a carpenter. If it was mixed school,
mm,
we do stuff like that. But
mm.
because I'm in all
Like that,
girls
yes.
yeah, because I'm in all girls
Okay,
school, they don't have it. We don't do it.
okay, okay, okay. Okay, that's nice. Okay. So you guys don't really have girls among you who would have loved to do core engineering disciplines like that, right?
Some do, but because because this is like the
Mm,
best school in this city. So that's why
Oh,
like people really come here
okay.
because
So
in
the
other schools,
focus.
yeah.
Yes.
So like in other schools, they have it,
Mm,
but because we are girls, they think oh, we might not have
mm.
interest. So that's why.
In it. Okay. Oh,
Yes.
I see. Okay. Okay. Okay, that's nice. I just thought I should find out a little about what you're doing.
What
It's,
do you like?
mm. You
Can
said?
you like about that computer? Like, is it more about like coding or
Yeah, yeah, coding.
like can you like elaborate more about it?
Okay. So what I see is that what what I could liken coding to something like it's a skill. You could call it a skill, and it's all about like writing programs and telling. It's like telling the computer how to do what you want it to do and give you a specific result, you know. And you could equally use it to solve problems like um, depending on what kind of problems you want to solve. If for instance, you just want to, have a program that would ask users for numbers and then um, do some calculations, basic calculations in the background, and then give them a result. So it's technically solving their problems. They are not the ones doing the calculations and all that. Okay, so it's based on what you've written in your code. So I think the aspect of thinking up your code constructively, like planning it, these are the things me I see as the um the the skills that coding will help you to like gain. I mean, you'll be able to, you know, think critically, um, you know, and come up with solutions to things. And then, of course, um, it's somebody would say if you look at some people might look
Some
at coding and feel that if they are not good in maths, they may not be good in coding, or if they don't like maths, they may not like coding. But it's not really so, because it's not every aspect of coding that is maths driven, or maths oriented. So yeah, it's just basically about problem solving creatively. Some of those um problems are creative problems. You might be like, okay, you want to write a program that would um, help a user um, find their total scores in all their subjects. So you
yeah,
start asking yourself, how would you do that kind of program? Just that thought process, and then after the thought process, applying it in a real computer, and then seeing the results. You feel like, oh, your program actually does does what you told it to do, and then it does it you know exactly how you imagined it would be. That thing about turning your idea into something that's actually working. I think that's the for me, that's the catch
Mhm.
for programming coding.
Yeah, I'll think about it.
Okay.
Yeah, because
Mm.
before I used to be like so obsessed with computer, and now, but that was when I was back home. But now I don't really have interest.
Okay.
But I would think
Okay. All right.
yeah, I will let you know.
All right. No problem.
Okay, sir.
Okay. Nice one. All right then. Enjoy the rest of your day.
Okay, sir. You too, sir.
Yeah.